This is section 17 of the M1 notes booklet, Equilibrium of a Lamina under parallel forces. We're on page 55 of the M1 notes booklet. As usual, this is video, so you may need to pause to take notes. It's not like a lesson where I would naturally give you time to copy up. You will need to pause for yourself. Right, so equilibrium. If you have an equilibrium of a lamina, then the components of every resultant force in any direction must be zero. So up equals down, left equals right. And the sum of the moments about any point must be zero. So for each point, the clockwise forces balance, the clockwise moments balance the anti-clockwise moments. Now if a lamina is not light, it has a weight. And that weight will act at the centre of mass of the lamina. For a uniform lamina, the centre of mass is at the midpoint. If it's non-uniform, then generally the question will be to find that centre of mass, find where the centre of mass acts. So, example 1. The uniform rod AB of length 6 metres, and as usual in mechanics we're going to start with a sketch. And mass 3 kilograms is pivoted at C where AC is 2 metres. Calculate the mass of the particle that must be attached to A to maintain equilibrium with the rod horizontal. So if we've got a particle at A, then its weight must be acting. We don't know the mass, so we're going to call it M. So the weight would be M times G. And the question's asked us to find this missing mass. Now, C is pivoted, so that has a normal reaction pointing upwards, which we're going to call C. And also we need to take into account the rod has a mass of 3 kilograms, so it has a weight at the centre of mass, which is halfway. So it's 6 metres long, so halfway is 3 metres, so an extra metre away from C. We have the weight acting down, so if it has mass 3 kilograms, the weight is 3g. And then to fill out the rest, 3 metres takes us to the rest of the way. Now we want to find the mass of the particle. We don't care what RC is, so basically the easiest way to create an equation that where M is the only unknown is to take moments about C. By taking a moment about C, the moment of RC will be 0, so we can ignore it. So again, we do my little table. So we've got 3 forces, mg, rc and 3g. So mg is 2 metres away, so 2 times mg is the moment. And around the point C, it would move in an anti-clockwise manner. RC goes through the point C, so it has no moment. And that's why we chose the point C. We don't actually have to choose the pivot as our point to do moments about. Any of the points, A, B, C, a different point that we made up along the line, they would all have a clockwise equals anti-clockwise for it to be balanced. Now 3g is 1 metre away, so 1 times 3g is 3g. 3g turns in a clockwise manner around C. And that deals with all the moments. For equilibrium, anti-clockwise equals clockwise. 2mg is equal to 3g. We can cancel out the g's. Divide by the 2. M equals 1.5 kilograms. Now that's a fairly straightforward example. You can have any number of forces in these. So example 2, a uniform beam AB of length 8 metres and mass 20 kilograms rests horizontally on supports at C and D where AC equals BD equals 1 metre. So A to B, got pivots at C and D either side. Again, these don't have to be to scale. because those are supports, they have normal reactions, so RC and RD. We've got a man of 75 kilograms at E, where AE is 2 meters, so another meter in. We have the point E, and there's a man of 75 kilograms and therefore a weight of 75 G downwards. We also have, the beam has a mass of 20 kilograms, so we need the centre of mass. It's uniform, so that'll be in the middle. It's 8 meters altogether, so another 2 meters in. Again, not to scale. We have a weight of 20 G, representing the weight of the whole beam. And then to fill in the distances, we have 3 meters. So, we need to find RC and RD, but at the moment we've got both of them in, so we can take our moments either about C or about D. By doing that, we'll be able to find the missing of the two. So I'm going to take moments about C. So you basically have to state which point you're going to take your moments about so that the examiner can follow your work. So we've got 4 forces, RC, 75G, 20G, and RD. Now RC goes through the point C, so 0 distance away, 0 moment. That means that the equation we get will only have one unknown in it. The 75G is 1 away, so 1 times 75G is 75G. It will spin in a clockwise manner. 20G is 3 meters away, 1 plus 2. 3 times 20G is 60G, and it too will spin in a clockwise manner. RD is 1 plus 2 plus 3, which is 6 meters away. 6 times RD, 6RD. But this one will spin in an anti-clockwise direction around C. So again, we do anti-clockwise equals clockwise, which gives us 6RD equals 75G plus 60G. Excuse me. So 75 plus 60 is 135G. Divide through by the 6. We get 45G over 2. And it generally is acceptable to leave answers in terms of G. Or to 3 significant figures. 221 newtons. Now, we could find RC by similarly taking moments about D, but once we've got one of the two unknowns, we can then employ up equals down. So our up forces are RC and RD. Our down forces are the 75G plus the 20G. Which gives us 95G. Stick in our value for RD. So RC plus 45G over 2 equals 95G. Take the 45G over 2 away from 95. We get 145 over 2. G, which is equivalent to 72 point... It's not. It's equivalent to 711 newtons to 360. Final example. So non-uniform lamina, so the centre of mass is not located at the midpoint. So we're in equilibrium from A to B, non-uniform, so we don't know where the centre of mass is. And in fact the question is to find the distant centre of mass from A. There's AC is 1 metre. And we say something about the reactions, so I'm going to fill those in a minute. We have, and D is 2 metres away from A, so another 1 metre in. So it actually turns out that D is at the midpoint. The magnitude of the reaction at C is half the magnitude of the reaction at D. Or the magnitude at D is twice that at C. So let's call the one at C R, and the one at D is 2 times R. Now the centre of mass, we don't know where the centre of mass is. Now experience in terms of how things balance means it's going to have to be between the 2 pivots, or else it would tilt either way. But in terms of the mass, we don't really need to draw it in the right place. Now we need to find the distance away from A, which I'm going to call x metres. And the mass of the rod is 5 kilograms, so 5 times g is equal to its weight. We're trying to find x. Now, if we take moments around any point at this stage, we'll have 2 unknowns, the r and the x. So ideally, we would like to find the r before we find the x. Now, we can still use up equals down first in this case, because up equals down will not have the distance in it and just the forces. And there's only one unknown variable for the forces. So from up equals down, r plus 2r equals 5g. Add them together, 3 times r equals 5g. Divide by the 3. R is equal to 5 over 3g newtons. So that allows us to know what R is. So R is 5 over 3g, 2R is 10 over 3g, times in the R by 2. Now we can take moments. How easy or difficult this is going to be is where we take our moments about. Now if we take the pivots, we'll have difficulties with this distance here. We'll have to work out what the distance in terms of x is to get to that centre of mass position. If, however, we take our moments about A, which isn't a pivot, but we still can take moments about it, it will be a simple, the moment to the 5g will simply be x times 5g, and we won't have any difficult algebra to do. So that's what we're going to do. We're going to take our moments about A. So force and moments, instead of calling it R and 2R, we'll call it minor force. So 5 over 3g, 5g and 10 over 3g. Now the 5 over 3g force is 1 away, so 1 times 5 over 3g is 5 over 3g newton meters. And spinning around A, it will spin in an anti-clockwise direction. The 5g force is x away, so as I've already discussed, 5g times x is 5gx. Spinning, it will spin in a clockwise direction. Excuse me. 10 over 3g is 2 away, 1 plus 2 is 2. 2 times 10 over 3g is 20 over 3g. We spin around A, it spins in an anti-clockwise direction. So we make our clockwise equal to our anti-clockwise. 5gx equals 5 over 3g plus 20 over 3g. which is 25 over 3g. Excuse me. Every term's got g in, so we can cancel by the g's. Divide through by 5 and we'll have our distance. So x equals 5 over 3, or 1 over 2 thirds metres. And that concludes this section.